Now, still on part 5, of course, coordination of electrical equipment. Okay, this used to say coordination of protected devices, so it's only really concerned with circuit breakers feeding other circuit breakers to try and make sure, as best we can, that we achieve coordination, we achieve discrimination, selectivity, where it is required. It now includes for more than just protected devices. You can see it's switching, isolation, control devices in there as well. Now, this is actually quite a new section in the 18th edition. It is very prevalent in the appendix for this section of the regulations. So it might make us think of that we always 100% of the time have to design an installation so that if you get overcurrent protected device 21, you can see trip there, it doesn't affect overcurrent protected device number 1, because if it did, then it affects 22 and we lose maybe the whole distribution board. Okay, yes, I agree that that is desirable, but that might come as a significantly increased cost. Overcurrent protected device number 1 may have to be a larger MCCB in order to provide discrimination, and the cost increase of that could be extremely large. So just because there's a lot more emphasis on coordination or discrimination or selectivity, there's no more requirements about supplying it. The sentence is, this regulation always start where selectivity is required. And of course, if it is required in hospitals and places like that, of course we have to provide it, and we have to kind of live with those costs. If it isn't required, if it isn't too important, okay, then we can manage those costs and perhaps accept coordination up to a certain level of fault. Overload protection of RCCBs and switches is something, again, we're not just trying to think about getting used to. We're trying to make it easy as a manufacturer, but it is a concept that we all need to understand. So there's a statement in the regulations now that RCCBs and switches in a standard consumer unit, you may see there, doesn't have to be a consumer unit, of course, it could be any distribution board, do not provide protection against overload. Therefore, they shall be protected by an overcurrent protected device. Generally today, they may not be. Okay, so in the consumer unit there, you can see we have a 100 amp supply to the property maybe. We may have a 100 amp consumer unit, but inside, quite usually, and you know, for the majority of time, certainly from the products we sell, the majority of the products are only 263 amp RCCBs in the consumer unit, which has been fine because the current rating of that switch or RCCB is usually based on the application of diversity, meaning you won't be using all the circuits to their full capacity at any one time, which is a sensible design process. However, because on the top line there, we must provide, or we shall provide, protection by an overcurrent protected device, overload protection, you cannot use the application of diversity to justify this overload protection. So, although in normal operations we take diversity, okay, what would happen maybe if our boiler packs up and we've got 3 or 4 3 kilowatt heaters in the loft? You know, we're going to get those down and we're going to plug those in. Diversity then kind of falls down. So again, we could quite easily overload any one of those RCCBs. So overload protection shall not be based on overload on diversity. We need to include for overload protection of those 2 RCCBs in particular in this picture. Now, some terminology is introduced, some definitions which I need to cover. IN is normally the symbol for current rating, which it is here, but it's IN with an A after it, is the current rating of the whole assembly. So this assembly is the consumer unit. And we can see here that it may or may not be the amps written on the incoming device. Just because that incoming main switch there might have 100 amps written on it, okay, the manufacturer of this assembly, i.e. the box with all the bits in it, has to state whether this device or this assembly is suitable for 100 amps, and it usually be on their literature, their labelling, or something like that in the with the product. INC is a section within the assembly, so it may be this section here. The RCCB with its MCBs after it is a subsection within that assembly. That again will have a current rating. Okay, not necessarily because it's got 63 amp on the RCCB. Can it be 63 amps once it's enclosed in that assembly? We're kind of used to the concept of changing the rating of cables when we enclose them. It's the same concept. If we enclose products, okay, be they cables, be they RCCBs or switches, we may have to change their rating or derate them slightly. So in this case then, with a 100 amp supply, if that assembly was rated 100 amps, okay, it may or may not be, if I was to say it was, okay, we are still not, in this case, providing overload protection to those two RCCBs. So how can we provide that concept and make compliance with this regulation? So you can see there that while this 263 amp RCCBs might be okay for the load current of the application diversity, being provided by a 100 amp supply means they are not overload protected. So what's the easiest way then of providing overload protection to those devices to ensure that they inside the assembly are rated at 100 amps? So now we have maximum 100 amp supply, 100 amp rated assembly, 100 amp rated subsections within assembly. It all fits, it all provides nice overload protection, and it makes the job very easy. So just choosing a 100 amp assembly with these devices in, or a 63 amp assembly maybe, if you are sure and guaranteed that supply to the installation cannot be more than 63 amps, maybe flats and apartments, it's under your control, is okay then. All fits together quite nicely, and the types of RCDs, which will be in this assemblies of course, will be type A RCDs. A new regulation, 5364-203, not a new concept, it was covered in the 70th edition but not in so much focus. A 203 number, actually any 200 number in the 18th edition, same as the 70th edition, is a UK specific regulation. So this is about integration of devices and components within assembly. So you can see in the picture there is kind of a device which doesn't seem like it belongs in this consumer unit. And I'm sure you've all seen consumer units with devices from different manufacturers that don't belong in that consumer unit. Okay, so a consumer or distribution board has to be certified by a manufacturer. So we at Hager have to obviously put our products together, give them several tests to make sure they cope with the heat, the fault rating, etc. And are compliant products, are safe products to put on the market. No manufacturer can test it with an infinite number of devices and components that go within that assembly. So you tend to test and verify your assemblies with your products in only. Okay, so you might say, why is this important? Okay, so because all, for example, miniature circuit breakers of MCBs are to the same standard, probably 60898, and all more or less to the same size, but they don't actually have to be the same dimensions to the millimetre. They don't actually have to have the same internal components organised in the same way. If it clips on a DIN rail, of course, the DIN rail size is set, so the actual DIN rail clip bit is set as a dimension. All the other dimensions, however, is up to the manufacturer how he wants to design his circuit breakers for width, height, depth, etc. So just imagine that a circuit breaker of ours on the left there has the buzz bar nicely fitting inside the terminal, gives a good electrical connection, doesn't generate a lot of heat, but it's been substituted for whatever reason, because that's the only one you got in the van or whatever, by a different manufacturer that was slightly shorter. You can see it might just be nipping the buzz bar. Okay, so if you do your electrical test on that, you do an earth loop impedance test or whatever on that product, you're getting an electrical connection, but you're not getting a good electrical connection. Once that's under load, this bad electrical connection is going to generate heat. It could generate too much heat, and ultimately, of course, it could generate fire. Also, the internal components do not have to be in the right direction. If you get a fault, there's a lot of energy inside this device as it dissipates the arc that's generated by this fault. And some superheated gases are produced inside, which have to come out. So there's always like a very small vent hole in circuit breakers to exhaust this gas. Now for our product there, that's just exhausts that gas, it goes up top, it goes above the MCB. So it exhausts the gas into a nice open space above the circuit breaker. Can you imagine then another device which was organised differently put in there, and the exhaust or gas was exhaust downwards below. Underneath the MCB is a buzz bar, and not too far away now, of course, it maybe is a metal casing of the consumer unit at different voltages. you could generate quite easily a secondary explosion in that consuming it. So it sounds almost petty, but it is really important you put the right product in the right casing, this distribution board. You are perfectly at liberty to mix and match and make your own, get your own enclosures, get your own devices in it. Switchgear manufacturers do it as part of their daily life, of course. Okay, but if you do so, you will be deemed the assembly manufacturer. Okay, so you will be like switchboard manufacturers. They do this, and they take the responsibility, and they have the appropriate insurances as an assembly manufacturer. Most installers, if not all installers, will not have this responsibility. They will not want to take on this responsibility. So basically, the guidance is do not do this. If you've got a Hager board, you put Hager products in it. If you've got another manufacturer's board, you put their products in it only.